In this video, we're gonna see if we can solve a general cubic equation of the form ax to the third plus bx to the second plus cx plus d is equal to 0. Now, the first thing we want to do is to replace our a with a 1, and to do that we're gonna divide all of this by a. So what do we get? We get a over a, which is 1, times x to the third plus b over a times x to the second plus c over a times x plus d over a is equal to 0. Now, to keep this one a little simpler, because we're going to do a lot of calculations with all of this, we're going to define some new variables. And the first variable we're going to define is variable g. And we're going to say g is equal to b over a. And the second one we're going to call f is equal to c over a. And and we're going to take h is equal to d over a. So now we get our new equation, which is just a little bit simpler, plus g times x squared plus f times x plus h is equal to 0. Now, to solve this general cubic equation, there are two main steps that you kind of have to know about. And the first one is very similar to what you do in a quadratic equation, which is the following. In a quadratic equation, you use this identity. You say x plus some variable k squared is equal to x squared plus 2kx plus k squared. And what you generally do in a quadratic equation, if you don't use the formula, is you say, well, I'm going to replace my quadratic equation with something that looks like this. K over 2 squared is equal to x squared plus 2, write it like this, 2k over 2 x plus k over 2 squared, which is just k squared over 4. And these two cancel out, so you're left with x plus k over 2 squared is equal to x squared plus kx plus k squared over 4. And what you do if you solve a general quadratic equation is you try to find a k, or you take your k. Let me make an example. If you have a general quadratic equation, let's say let's pick just some random equation, plus 5x minus 3. What you try to do is you try to find an equation that looks like this, that is equivalent to this statement. So what you do is you say, well, this is my k, so I'm going to say x plus 5 over 2 squared is equal to x squared plus 5x plus 5 squared, which is 25, over 4. And now to get to this equation right here, all you do is you add or subtract as much to both sides of this equation to get the same as this. So this is not the best example. We have to subtract here minus well, we could say that -3 is equal to let's make it fourths, so we multiply by 4/4, so what we'd get is -12 over 4. And so to get to -12 over 4, we have to subtract 25 and another 12. So 25 plus 12 is 27, is 30, is 37 over 4. So let me erase this. So, and we do that on both sides, so we say negative 37 over 4 on this side as well, so it stays, the value on each side stays the same, right? So we get our equation x plus 5 over 2 squared minus 37 over 4 is equal to x squared plus 5x plus 25 minus 37. Well, we just said that that is -12 over 4, which is equal to -3. So we have x squared plus 5x minus 3. And then you can solve this equation because you know that all of this is equal to 0. That is how you solve for this. Now, we don't want to solve a quadratic equation. We want to solve a cubic equation. But the first step in solving a general cubic equation is very similar to what we just did here. Let me just delete all of this right here. And what we do in a cubic equation is very similar. We say, what happens if I take x plus k over 3 to the third power? Well, what do I get? I get x to the third, right, plus 3 times x to the second times k over 3. So these 3's cancel out. Plus 3 times x times k to the second over 3 to the second. So it's k to the second over 9. So these cancel out and I'm left with 3 right here. Plus k to the third over 3 to the third, which is 27, right? Alright. So what we're left with is x plus k over 3 to the third is equal to x to the third plus x squared times k plus k squared over 3 times x plus k to the third over 27. Now, what we do from here on out is not exactly the same as what we did for the quadratic equation, because we can find, or at least I don't know how to find a k that fits g, f, and h in a general case, you know. So what we do is we say this kind of looks like this, like these 2 terms up here, right? We have an x to the third when we have an x to the second times some k. Here it's a g. So what we can do is we can rewrite x to the third plus x to the second times k as being equal to x plus k to the third, k over 3 to the third minus k squared over 3 times x minus k to the third over 27. Now, why would we want to do this? Let's see. Because here we're left with a term that is to the power of 3. Let me use another color. Here we have a power to the third power, you know, our x to the third power, and here it's just an x. So we've lost our x to the second, which is, you know, if you look at the equations, which we'll do afterwards, this will be a lot simpler to solve for than this, because the second power is missing. So you have a 3 and then you have directly a 1 and not 3, 2, 1. So let's just do this. Let's substitute this term with this up in the original equation. So what do we get? We get x plus our k here it was generally a k, right? But we have a g here, so it's a g over 3 to the third minus g to the second over 3 times x minus g to the third over 27. Then we add all of the rest plus f of x. I'm just going to stay in yellow here. F of x. Oh no. Plus f of x plus h. And all of that is still equal to 0, right? So what are we going to do now? We're going to group our terms, right? Our x terms and our constants. We're just going to regroup all of this. So what do we get? We get x plus g over 3 to the third minus, well, let's say plus. Let's say plus. So plus, we're going to factor out the x. So what we're left with is f minus g squared over 3 times x. And then we're just going to subtract all of our constants. So we have plus h minus g to the third over 27. And all of this is still equal to 0. So what are we going to do now? Well, what we could do is we could define a new function or a new variable so that this whole thing becomes a little bit simpler to look at, because notice we still have only our x and some constants that we can calculate from our a's, b's, and c's, right? A, b, c's, and d's, I want to say, right? So what could we do with this? We could say this, we could say our new variable y is equal to x plus g over 3. And what would that mean for our x would be then be equal to, we can just solve this for x. So what we get is y minus g over 3. So now let's make this substitution, right? This here is going to be y, right? We defined y as being this, so we get y to the third plus. Now all of this we're going to just keep in like this, so it's f minus g to the second over 3 times x. Well, what is x? We said, well, x is y minus g over 3. So we're going to put that in. It's y minus g over 3. And like this. That's this here, right? And then we're just going to add all of our constants again, plus h minus g to the third over 27, and all of this is equal to 0, right? Right. Now we're going to do a little more of algebra. We're going to multiply all of this out. So what do we get? We get y to the third plus f times y, right? We're just going to distribute this. F times y plus minus f times g over 3. So we're going to get minus, oh, and I wasn't consistent with the coloring here. This isn't a constant, this is our y. So our y, f times y, and the next one is going to be constant though, because it's f times g over 3. And so what's the next term? It's minus g to the second over 3 times y. So what do we get? We get minus g to the second over 3 times y. And the last one is minus times minus, which is again plus. So we get plus, and we get a constant, so it's g to the third over 3 times 3, which is 9, which is 27. 3 times 3 is 9, which is 9. Getting confused here. Alright, plus h minus g to the third over 27 is equal to 0. Now this doesn't look a lot better than what we had before, but we're just going to regroup this, and hopefully, well it will get better. So it's y to the third, and we're going to group the y terms again. So what do we get? We get plus f minus g to the second over 3 times y, and then we're just gonna be left with a bunch of constants, which is f g over 3 plus h minus g to the third over 27. And did I forget something? This one we have there, this one, and plus g to the third over 9. Now we can simplify these last two terms, because the common denominator here would be the 27. So 27, this times 3, so we have 3 times g to the third over 27 over 27. So we're left with 2, right? 3 minus 1, that's 2. So we have plus 2. I'm making a mess of things, but we're running out of space on this page. So we're left with 2. We're left with 2g to the third, g to the third over 27, which is equal to 0. Now, this looks interesting. This here, we can rewrite all of this as a relatively simple looking equation, which will turn out to be not as simple, but you know, it's simpler than what we started out with, because we can define some new constants, right? We can always do that. So where did we stop with our letters? We had all of these, so we'll just go J, K, and L, right? I'm not great with the alphabet, so but we're not going to take I because we're going to use I later. So we're going to use J as being equal to F minus G squared over 3, and we're going to say K is equal to minus Fg over 3 plus H plus 2g to the third over 27. And what does our equation look like if we substitute these into there? It looks like this: y to the third plus j plus j times y plus k, and all of this still equals 0. Now, what have we done so far? We have taken a cubic equation of the form ax to the third plus bx to the second plus cx plus d is equal to 0, and we have successfully rewritten that equation in a form y to the third plus jy plus k is equal to 0. And this looks simpler to solve. And as 23 minutes have already passed, or something over 20 minutes have already passed, I'm going to stop this video here, right here, and we're going to see in the next video how you can solve this equation right there.